Right.
All right, so good morning, good afternoon, and welcome to this session on best practices for operational ocean forecasting. I'm just giving a very quick overview before passing on to Enrique, who will continue on the theme of operational oceanography and how we're getting structured and so on. And I look forward to that talk. Here, I'm just going to lay out a bit what Ocean Predict does, and also with our new initiative or a new for federating or assembling the operational ocean forecasting systems together. They used to be represented individually in Ocean Predict or in this large consortium for ocean forecasting. And now we're sort of, with David and I, we're joining things as a group to that also leads us to why we need best practices and so on, so that we're more coordinated and more consistent, say, across ocean forecasting systems, but also people know what to expect when, someone says they have an ocean forecasting system, or what to expect on accessibility, etc. And that leads us to reporting and the best practices in reporting to go forward. Now I'm just trying to figure out how to move my... I'm assuming everybody can see the screen, no problem. So I'll continue unless that's not the case. So operational oceanography is really the provision of routine oceanographic information, and whether it's for reanalysis or whether it's for long-term in the future or for immediate next 2 days and so on at high resolution, the idea is that it's a structured way and a routine way and an operational way for delivering information, just like in the weather forecasting network. And we can look at it as different components that you see up here: the observation network, the prediction and the data assimilation system, the service delivery in red and the end users in red, because those are more client focused and so on. And then data management and monitoring systems for all the data coming in and all the data going out is also very important. And in Ocean Predict, we're focused on the prediction system, but we're embedded within that whole infrastructure for operational oceanography, which well, Enrique will probably talk more about and how that gets organized. So from the ocean prediction perspective, there's a lot of different systems out there, from global systems at very high resolution, some of them for 1/25th for the HICOM system in the US, and then going with increased resolution for regional or basin scale prediction systems, like for the Mediterranean, for the Arctic, etc. And then we have coastal shelf prediction systems, which at the moment are around 2 kilometers or less. And then we also go right down to port prediction systems, which really zoom into a particular port at very high resolution and provide a lot of intel for people approaching the harbor, etc. And Spain has an excellent network of 100 or so of those ports, and other countries are also starting to develop these port systems. As far as the sort of groups that we represent, at the moment, it's mostly large institutions and so on in ocean forecasting that are mostly linked to weather forecasting. So there's synergies with the WMO and with the IOC. And we're also connecting particularly space agencies and so on for their space observation systems, but as well as Goose and the Argo program, etc., are important parts. And for end use applications, we have fishing, Coast Guard, navies, environmental consultants, fish management. And as we go forward in the future, more and more specific end users or individual end users or small end users. And in order to cater to all those internationally, we need standards, etc., to or best practices, and then eventually standards to sort of make sure that things are interoperable and people can use whichever system most suits their needs and understand how these systems are presented. We had a big meeting in 2019. That was long before COVID, thank God. And we set, there was some goals coming out of that symposium about setting standards and best practices. Right now, we're at the best practices, and this is why we're here today. And Enrique may talk about the standards coming up and so on. But the first step for us is the best practice. And we want to engage a bit in capacity building, provide better connections with end users in partnership with others, and also sort of promote ideas of working on new subjects, but in a cross-cutting manner, multidisciplinary. So where ocean best practices helps us is, well, under the decade of ocean sciences, there's a lot of input being put in, or a lot of groups participating. And how do we connect everything to be able to, you know, provide an overall benefit for, well, I'll say humanity, or for society. And part of this will be the digital ocean, or the DITO approach, in which we'll be engaged in. And Enrique, I think, may talk about a bit more. That digital ocean side is like a digital twin, and it's sort of a unifying piece that will allow for information exchange and so on. But to participate in that, we need standards, or the standards will be important, so that it'll be easy to access things through different APIs and so on for the output. And then one thing also to mention is this new working group, OBPS working group, that's going to be quite instrumental. This is just a quick slide about overviewing Ocean Predict. On the left, you see the working group, which is all the operational systems that we have at this time included. And then on the right, we have the task teams, which are sort of more by type of research or type of discipline, whether it's data assimilation or coupled modeling or coastal ocean and shelf seas. And just also wanted to highlight ETUS, which is an external group, but we include them as if they were a task team, and a very important task team, so that we're connected to them as we go forward in this new era. I've already talked about task teams. So now on the reporting is that every year on an annual basis, we would do a report for each system would do a report. And now our challenge is to say, well, what's the best practices? What is it that we need to put in these reports? How do we make them more consistent from one system to the next, and also more useful for a variety of end users and stakeholders for ocean forecasting? So so the working group is focused a bit on best practices at the moment, particularly with regards to reporting, but also building up best practices over time for all ocean forecasting systems in general. And then just to say is, while this group looks at best practices, you know, another group, which will be ETUS, looks at standards or setting the standards, but this will feed into that group, and I'll leave it at that for now. Last slide is how can we be useful? What do various groups need? And what we're looking for is, you know, to get consistency across all the reports, and also submit these reports so that they're in an exploitable fashion for various users. Thank you. I'll leave it at that. Back to you.
Thank you very much, Fraser. In the interest of time, of Jeff, we go on to Enrique straight away. But if you have any questions for Fraser, please put them in the chat, and I'm sure Fraser can respond there. So, Enrique, if you're able to share your screen, please.
Should be now shared. Do you see the presentation? Can you confirm?
No, can just see you on video.
Okay, I'll try again. I don't know what went wrong. Is it okay now?
Yep, can see that now.
Thank you very much. So thank you for the opportunity for being with you and for giving me this slot to explain what we are starting to build. Is this Ocean Prediction Decade Collaborative Center, and our motto is connecting the world around ocean prediction. So this is what we have planned for the decade. This is what I like to call the Ocean Prediction DCC voyage for the decade. On the left, this is what we have today. Very useful, very important systems running, but these are partially disconnected. I will explain later what I mean by partially disconnected. And also because they are difficult to implement, there are not so many around in less developed countries. So the idea is that by the end of the decade, we will have much more systems running, especially having focus on less developed countries, and those systems will be much better connected between them. They will be able to use common tools. They will be able to use to take benefit of common artificial intelligence tools, validation tools, etc., etc. And they will be more robust. So how we are going to do this? We are going to do this, the captain, our big opportunity is the UN Ocean Decade. The engine will be run by the decade actions such as 4C, which is critical for this, such as Coast Predict, DITO, and also we will have another engine, which is the impulse that we are receiving thanks to all the digital twin of the ocean initiatives. Who is going to be with us? This is the Ocean Prediction DCC community. I will explain later what this is exactly, and we will just limit ourselves to serve as inspiration for these developments. So we are not going to be the ones having the resources to do the developments, but we are going to be the ones that working with everybody, working with the decade actions, working with Ocean Predict, we will be able to help in inspiring the path to reach to this new environment. So this is our vision, a predicted ocean based on a shared and coordinated global effort in the framework of the UN Ocean Decade. And how we are going to do that is by galvanizing and coordinating efforts towards co-developing and integration of worldwide ocean prediction activities in the framework of the decade. We have two main pillars for doing this. The first one is the community. I mentioned it that we were doing this travel with the community. So the community will be our boots on the ground for working. And we are thinking here in a very transversal community that goes beyond the classical scientific composition. We will try to attract private companies, we will try to attract users, we will try to attract even just interested people in these topics. There's a bit of noise around. Maybe you can close your mics. Thank you. And so we need to organize two regions. And what we have decided is to take mainly the best of both worlds from UNEP regional seas and GOOS regional alliances, and we have created therefore our own distribution of the seas and of the ocean, and we are plugging all these regional seas into our regions, and the same for the GOOS regional alliances. So we can take, as I said, best of both worlds, and these teams will be in charge of identifying gaps and ways forward, contribute to Ocean Prediction DCC community tools. I will talk about this in the next slide. Work with us in capacity building and ocean literacy activities, and the reason of this meeting, advocate for implementation of best practices, standards, and tools. I will explain later where these standards come from in the framework of this activity. So all this community building is now just starting. Soon we will, I think that next week or maybe tomorrow, I don't know, launch a bidding for the development of the web page and a series of tools associated to the web page, including a tool to develop an atlas of worldwide ocean forecasting services, persons and institutions involved in these activities. Then the tools guide that I hope that you have already seen will be converted into this page into a wiki to keep it alive. We will have a forum, a classical internet forum with questions, answers, meeting point, and then we will have also a section on news and events. It's important that we are going to have a kickoff meeting to launch all these activities in January 2023. And we will put activities on that meeting, during the meeting, to gather more information for the atlas, for the forum, etc. And to finish or better, really start building the community. Also, we will do some capacity building and ocean literacy activities, but we have not started yet, and we are far from start on this side. Our idea is to start mid-2023. And now at this moment, what we are just is getting ideas for this, what is needed in terms of capacity building and ocean literacy. So if you have an idea, please let me know, because I'm building this pool of possible ideas that with time could be developed. So please save the date. Our kickoff meeting is 11 and 12 of January 2023. And it will be, I think it will be really nice, because we will have several activities, and one of the things we will have is a virtual booth, virtual exhibition of existing operational forecasting system. Obviously, we will develop this in close collaboration with Ocean Predict and with Coast Predict and others. The idea here is that the visitor will be watching the different booths, the different virtual booths of the existing operational forecasting systems around the world. So it will be like visiting an exhibition of existing systems around the world, and it will survive it's not just for the 2 days of the meeting. So we will launch it there, but it will survive the meeting, and it will become a permanent exhibit and live exhibit of existing operational forecasting service that will complement the atlas. The atlas will be more technical, and this will be more friendly and just informative. So this is pillar number one. Pillar number two, which is the one really more related to the standards and best practices, is, as I mentioned it, the gaps. A big gap is that the systems are partially disconnected. What does this mean? It means that, for example, during development, new systems require development from scratch. If you are in one institution in one country, because that was our experience when we were in Portos and we wanted to develop a new system, then basically you have to start studying and learning from scratch what to do. And also, on top of that, the existing core services, things from the States and things from Europe, are quite disconnected and are not interoperable. So these are problems during the development phase. And then during the exploitation, if you are smart enough and you have money enough to finish your work and end having let's imagine a coastal high resolution system, then your system is not well connected with the rest of the world, because you don't have possibilities to use common tools for validation, dissemination, and exploitation. So for example, you don't have access to joint validation tools. So what is the opportunity to change this scenario? The opportunity is dedicated as a game changer, and also the technical opportunities that will be derived from the digital twin concept that is reaching with a lot of force. How we are going to help in solving that? How we are going to help in advancing in this direction? First, so I said not solving the issue, but towards a solution. Then we will build a team, an ocean forecasting co-design team that will work initially in designing a new architecture, thinking about tools, standards, best practices, etc., in cooperation with all these important decade programs that I mentioned before. The idea is that once we are able to design this architecture and put it on paper, write it on a series of papers, this will be an inspiration for decade programs to do to define their own development targets. So if we are able to put together to co-design this architecture, put it on paper, then the decade programs could build the different bricks, the different tools, best practices, and standards that are required. So those are, please don't take very seriously. This is light. This is just examples of what I'm talking about when I'm talking about defining an architecture. You can imagine here on top an architecture with several core DTOs, one in Europe, one in America. You have here that all of them should be connected. Then you have the visualization and discovery tools, data mining tools, artificial intelligence. And then you have the coastal systems, which if good enough, if good quality enough, they should be able to enter into the interoperable data lake and access all these tools of visualization and discovery. And to make sure that they are good enough, we have here ETUFs in a new role of an endorsement role, qualifying systems and checking that they have the standards to be able to join this family. This is another architecture which is more complex because here the DTO is more advanced and you can launch operational system from inside the DTO. But this is, please don't, as I said, those are other digital twins that are connected, for example, the digital twin of a port or the digital twin of a ship, which are also of the interest for the interest of the user. So please don't consider this as a final outcome. This is just an example to explain when I'm talking about possible architectures, what I'm talking about. So I was coming back, I was talking about this arrow here, number 4, that is the one that qualifies the operational system and say, okay, you are good enough to be part of the family. And we can achieve this through this concept, which is the operational readiness level. The idea here is to develop together with 4C and others, this concept, which will be 4 independent digits to describe the degree of operationality of a system. The first one, again, this is an example, not the final product. The first one is the degree of operationality. The second one is how the technical solution how the technical implementation is fit for solution. The third is how well are you doing the validation. The fourth is the how well are you doing your dissemination of your results. So imagine that once you are, for example, 4, 4, 4, 4, then you are good enough, then your system is robust enough to go into these digital twin families and be able to benefit of all these new systems. So what are the benefits if we are able to build this? The benefits is that we'll be a very strong force for the adoption of tools, standards, and best practice. If you say that for having more than a 4 in output dissemination, you need to use NetCDF format, I don't know what, or whatever is the format we decide, or the formats, then people will want to adopt these standards. It's a mechanism to endorse services to join common framework. One of these joint common framework could be these digital twins, I explained it before. And it's a way to guide how to and to stimulate the service development. So maybe you are excellent on data dissemination, but you see, thanks to this index, that you are not as good as you believe in operationality. And then you are interested in improve your operationality. So how we are going to do this is that thanks to this ocean forecasting co-design team that will start working on February. Hopefully that's the plan, February next year. And the idea will be to start with a core team, small team that will basically define the way forward and start moving the whole thing. And then if needed, additional teams will join looking into the value chain. For example, connection with observation, forecasting engines, that's the models and artificial intelligence stuff, how to downscale, link with users. This is to be defined by this core team. So the idea is first to create this core team and then start working with this. That means that in the future, we will have this map, we will have this specification, and we will hopefully be able to start during the decade delivering this thanks to the collaboration with the decade programs and actions. So ETUFs, how does the new, sorry?
2 minutes.
Okay, how does the new ETUFs link on all this? So this is how the loop of a standard will be executed. So first, the UN Decade programs and action together with Ocean Prediction DCC, we have the definition. We identify this need of a new standard or tool. then it is the decade actions, the one that are in charge of the development of this new concept. Then ETUPS, on its new role of endorsement, is the one saying, okay, this is good. This is developed with respect to the specification. So we are good with this. And then it is best practices and again, ocean prediction, the ones in charge of disseminating this to the community. So to finish, ocean prediction DCC, we hope it's going to be a key element for the ocean prediction we need. We will build on an active community that we are now creating of users, scientists, policymakers, and even just interested people. And we will have additional focus on developing countries, as I mentioned. We have to take the advantage of this decade framework and the arrival of the concept of digital twin. This is our opportunity to advance. And if we are able to even partially succeed on all our very ambitious objectives, we will, by the end of the decade, have a better connected community, new and better forecasting services, and a technologically linked worldwide ocean forecasting network. This is a significant challenge, which is obviously possible through a heavy collaboration with decade programs and other relevant actors. So I finish again with my idea of connecting the world around ocean prediction, which really goes beyond the technical ideas and is using ocean forecasting as a focal point to foster intercultural dialogue towards the ocean we want. Thank you.
Thank you very much. Does anyone have a quick question for Enrique? Anyone? In that case, I'll ask one. What do you see operational oceanography looking like in 2030?
Sorry, I was not able to hear.
In 2030, how do you see operational oceanography being different to today?
I think that the key is that, at least with respect to, I think that the key is that we will be able to interact in such a way that we will not duplicate efforts and that things will be easier to implement. I think it's a little bit like what is happening with the software. When we started, we needed to code everything slowly and with a lot of care and love in Fortran. And now young people arrive and they have Python routines to do things. I see that in the future, everything will be much more plug and play. So somebody arriving from a developing country will be able to develop their own systems because they will have their own plug and play things to build based on that. And therefore, you will not need this huge learning curve that the ones that have had few more years have suffered or enjoyed in the past. So this is the big change I foresee.
Yep. Okay, thank you very much.
And obviously standards are critical for this.
Yeah, I fully agree. Yeah, if you have any more questions, please put them in the chat. Otherwise, Regina, are you ready to talk?
Yes, please. Yes,
Hello.
please. There's a question. Should I?
Sorry, shall I go to the chat?
Nothing in the chat at the moment, but if you keep an eye on it.
Okay.
And yeah, Regina, if you could share your screen if you're able, please.
Yes, please. Thank you. Okay. Can you see my screen, please?
Yes, it's not in presentation mode, but we can see it.
Yeah, okay. I'll put it in presentation. Okay.
Yep, perfect.
Yes, so my talk first of all, I want to thank the organizers for this opportunity to give this talk, and I hope we have future interactions. Thank you. Operational oceanography, implications for ocean best practices in developing countries of Africa. This is Africa's 63,000 kilometers of coastline, which is crucial to the economies of many of its states, especially through oil and gas, fishing industries, and tourism. Some island states like Seychelles, Mauritius, almost entirely depend on their coastal resources for income. Africa's coastal and marine areas have important living and non-living resources, oil and gas especially. Many countries in the Western Africa, for example, are oil producers, with Cameroon, Gabon, and Nigeria being net exporters. Exploitation of these non-living resources has changed the coastal environment. And in the case of oil production in the Niger Delta, it has led to civil unrest. The coastal zone, the issues there are such that coastal populations in Africa continue to grow, and pressures on the environment from land-based and marine human activities increase. Coastal and marine living resources and their habitats are being lost or damaged, diminishing biodiversity, thus decreasing livelihood opportunities. Degradation has become increasingly acute within the last 20 years. The coastal hazards, coastal erosion, pollution, fish stock depletion, habitat destruction, biodiversity, coral bleaching are some of the pointers. Now you can see pictorially what I mean by that. The West African coast of Africa is the home and origin of the South and Central Atlantic weather systems. And these systems build on the east coast of Africa and migrate towards the west coast. And it is also experienced in America. For example, in August 26, 2011, a large and powerful hurricane Irene made landfall in the United States. And Irene was a Category 2 hurricane, yet it sustained a wind speed of about 100 meters per hour. The meteorological and weather systems, the ANC interaction leads to flooding along the coastal areas of West Africa. That is flooding due to storm surges or flooding due to rainfall. And the coastal flooding, these are meteorological factors and are seasonal and cyclical. So flooding due to meteorological factors are now everywhere, and we all have issues. Now, with climate and natural disasters, stroke hazards, global sea surface temperatures has increased. Tide gauge data shows a rise in sea level. Model simulations indicate that a doubling of carbon dioxide by the year 2100 will result in mean global warming. Global warming will cause mass expansion of seawater, melting glaciers, and rise in sea level. Scientific evidence already points towards discernible climate change. This is likely to alter the frequency and magnitude of natural disasters, hazards. So, what then do we do? The challenges for the 21st century: how to provide and effectively use ocean products for appropriate decision-making is one of our main concerns. Then the climate change variability and natural disaster, how to cope with increasing climatic extremes, potential impacts of global warming, that is in terms of mitigation and adaptation strategies for sustainable agriculture. Then food security is also our primary challenge in the 21st century. So the management of the hazards and disasters along the coast. The best way to confront natural disasters is to create a culture of safety among the communities at risk. And the communities depend on the scientists in the region to give them answers to this. Enhance the capacity of the people living in vulnerable areas. Then the preparedness, that is having a cross-sectoral approach in putting up early warning system, is one of the issues we are also dabbling with. And any sustainable management of hazards and disaster in the coastal area will require the integration of ocean data and information in all aspects of planning. Now, operational oceanography is the emerging research field devoted to the science and technology observing and forecasting of our oceans and seas, important for improving safety and efficiency. It enables the sustainable exploitation and management of ocean resources such as fisheries. We know it will support safe and efficient offshore energy-related activities. It will mitigate the effect of environmental hazards. It will contribute to ocean climate variability studies and seasonal to interannual climate prediction using appropriate methods and standards. This will give us the forecast, the nowcast, and the hindcast we need for analysis. Now, let's look at the components of operational oceanography. The Coriolis component is such that we should have sustained and enhanced AGO network. This sustained and enhanced AGO network along our coast, you see that when you have the global network of AGO floats, our nearshore environments have none. And then this is the voluntary observing vessels. And this one, we used to have it during the 1990s, late 1990s, but they are no more operational. We do not see them again. And then they have to maintain pirata observation systems for collecting in-situ data from MOD. Now, I will talk more about this when I show you the next slide. And we have to have the buoy, which is the MOD buoys. Then we have to deploy surface drifters. These are all the components of operational oceanography. We are to operate and maintain high-frequency coastal networks, operate and maintain French sea level networks. Now, the next slide tells us that, for example, the distribution of tide gauges, this one, when you look at this map, the coast of Africa, it's only very few areas that you see the active tide gauges. Here, they are non-active. All these areas are non-active. Now, when it comes to drifter array, the coastline of Western Africa, you see that we do not have the normal dots that should signify that they have drifters. MOD buoys, that is, for example, the Pirata. The Pirata stopped working 2017, and that was established here because the Pirata is such assembled that when coastal fishermen see it, they have a mind expansion with regards to how to use the different components for their different vessels. So this doesn't work very much in Africa. Now, looking at the value chain of the operational oceanography, yes, we have societal requirements as we have already highlighted. These are the best practices. Then the scientific approach here, in our context, it is a big question mark because we do not have the necessary data acquisition properties. And then when you come here, it is to look at how the data is managed, the collection, the selection, the QC, how it is converted into formats for integration into computers, transformed into products and services. Now, so you see that there is a big disconnect from this area, that is from the data acquisition to product services. There is a big disconnect where the Africans can participate. All we know is that, yeah, there are products and services which we will now have to fine-tune or talk about for societal benefits. So operational oceanography, all the value chain of it, in Africa, there is a big disconnect from the scientific approach to the products and services. So what is the way forward? I'm proposing we should have a coastal operational oceanography, data assembling and processing center in the African coastal environment, where data assembling and processing centers are essential elements of operational oceanography infrastructure. That will provide data, products, and best practices formats needed for modeling and data assimilation systems. They are also to provide products directly usable for application. But in Africa was a success story in this regard. And I think the framework of this is in the whole Odin Africa operational oceanography, Odin Africa, all the best practices are found within the framework of Ocean Africa. So how should the coastal operational oceanography in Africa be enriched? The best way to implement the coastal operational oceanography system is to finance this measure with a top-down approach, that is from international networks to the more local ones. The framework of best practices can then be instituted if we want to make it useful and taking into account the local content and potential users of this measure. Then we have to adopt a bottom-up approach. African operational oceanography adopted to the global oceanographic programs will make the best the best way forward for the ocean decade. Thank you for listening.
Thank you very much. Anyone have any questions? Please either raise your hand or just speak. If not, I'll ask a question. What variables do you see as most important? So wave or storm surge or temperature, primary production, or a combination of all of those?
Thank you very much for the question. A combination of all that is the best way forward, because the weather elements, they are a mixture of SE interactions, and we will need something that combines both.
Okay, that's very interesting to know. Thank you. Okay, in that case, we'll move on to Ken, and yeah, any more questions, put them in the chat, and I'll also just note, please take note of Jay's comment in the chat to log your details in the theme session if you can. But yeah, Ken, please.
Okay, hello everybody. Can you see my screen all right?
Yes, we can.
Great. Well, thank you very much for the invitation to speak. My name is Ken Milne, and I'm from the Met Office in the UK, but I'm speaking here on behalf of WMO, the World Meteorological Organization. And I think actually, just looking at the very last slide of Regina's just now, this talk follows on quite well. She mentioned the idea of a top-down approach. And what I want to talk to you about is what we call the WMO cascading forecasting system for capacity development. But that's best exhibited through what we call the Severe Weather Forecasting Program, which is the main topic of this talk. And this is a mechanism that we've used in weather forecasting to try and support capacity development in developing countries, in least developed countries around the world, and which I think could be easily modeled for capacity development in the developing countries. And it is a sort of, to some extent, a top-down approach, but it's a top-down approach which still tries to engage the national Met services and therefore be fully engaging of the local Met services as well. So the idea is to be able to bring advanced weather forecasts to everyone, and particularly severe weather warnings. And I don't expect you to look at all the words on this slide, but the challenge that we're facing is to try and make sure that we can give, that everybody can access basic warning services. And this has been brought to light particularly this year when the UN Secretary General, Antonio Guterres, issued a challenge to the world, or to WMO, that early warnings and action save lives. And to that end, he announced that the United Nations will spearhead new action to ensure every person on Earth is protected by early warning systems within 5 years. And that's a challenge to the World Meteorological Organization. And the opportunity that we have to address that is that advanced centers, the big national Met services around the world, run global forecast systems with the capability to support early warnings anywhere in the world. And WMO operates a network of national centers in other words, the national meteorological centres, with responsibility for warnings in their countries. So it's bringing those two together to try and provide a service everywhere. Now, this is done under what we call the Global Data Processing and Forecasting System, which is essentially a worldwide network of operational centres operated by WMO members. And the diagram on the right is a bit complicated. It tries to set out the different types of centres that we have. The key bits are, if you like, that we have what we call world meteorological centres and regional specialized meteorological centres. Now, each RSMC has certain types of responsibility, and different RSMCs will have different responsibilities. But particularly on the left, it just highlights some of the different types. And I'm most interested here in some ways in, well, the general purpose activities often might include, for example, running numerical models and making numerical model output available for others to use. And the specialized activities can include, for example, what I'm going to talk about, which is severe weather forecasting and providing guidance to regional centres. Apologies for the little messages that are popping up on my screen. They're going to get in the way, I'm afraid. And at the bottom of this diagram, we've got the national meteorological centres, which are should be in every country to provide weather forecasts and services in those countries. So again, I don't expect you to see all the detail in here, but these maps just give a broad indication of the number of different RSMCs and World Met Centres that there are around the world. There are 10 World Met Centres, all of which have global forecasting capabilities, and then around 150 regional specialised Met Centres, which have been designated. The map on the right is for long-range forecasting. The one on the left is for nowcasting to medium-range predictions. That's the more relevant one. But you can see that there's a lot of centres around the world with a range of different types of activities. And as I say, I don't expect you to see all the details in there off the slide. But one of the key part of this activity I want to talk about is what we call the Severe Weather Forecasting Programme. And so the map on this slide shows that we now have 9 different severe weather forecasting program projects around the world, each one centered on a local regional center, which then supports other countries in the region around it.
Yeah.
I'm just hearing somebody else speaking. Maybe someone else would like to just mute their microphone.
So I send it to you. When you finish this meeting, I mean that meeting that Oga said I should attend. This mission.
So I'll just try and talk over whoever else is speaking, but please, if you can mute your microphone, please. So SWFP started as a demonstration project in Southeastern Africa region in 2006. With just 5 countries and support from Pretoria in South Africa. Later in 2009, it was expanded to the whole of Southern Africa sub-region with involvement of 16 countries, and that is now operating as an operational service. In the following years, after the initial project start, there were a number of other projects initiated around the world. First of all, in Southwest Pacific, around New Zealand, and then extending into East Africa, Southeast Asia, and now 9 different projects around the world. And these are at different stages of development, but quite a number of them are now operational. So all of these projects use what we call this cascading forecasting process. And they start from, in this diagram, I'll spend a little time on this diagram, which tries to illustrate what this cascading forecasting process is. At the left-hand side, in the blue in the middle, we have these global centers. These are often the World Met Centres that I mentioned. And these have global forecasting capability, and they make NWP, that's numerical weather prediction data, and ensemble prediction data, which allows us to understand the uncertainty in a forecast as well as just the most likely forecast. It makes these data available to others for use freely. Now, not necessarily at full resolution, but these centres make this data available. And this data is cascaded to the right to these regional centres. And these are designated as RSMCs for severe weather forecasting capability. So, for example, in the one that I mentioned earlier, in Southern Africa, that regional centre is the South African Weather Service in Pretoria. And that regional centre takes these global products, global data, and derives from it some guidance on severe weather risks and things for the region of responsibility. So in the case of Pretoria, that's these 16 countries in Southern Africa. And then they cascade that guidance out to the national Met Centres. So even though those national Met Centres may not have their own numerical models, or even they may not even have the capacity sometimes to be able to download the data directly from the global centres because of low bandwidth connections and that sort of thing. But all they need is an internet browser to be able to see the guidance and things that comes from the regional centre. And then that gives them the forecast data that they need to be able to issue warnings and basic forecast services in their countries. So this is a way of making sure that every country should have access to the data that they need, the real-time live data, operational data that they need in order to be able to provide basic warning services within their countries. The rest of the diagram indicates some of the supporting things that go around this. The supply of satellite imagery, and for example, other observational data. And there are mechanisms for providing feedback back to the global centres about the usefulness of their data and that sort of thing. But the key thing is this cascade of data from the global centres through a regional centre, which provides guidance, and into the national Met Centres. I'm now just going to illustrate to you a couple of the sorts of things that come out of this. So this is an example of the website that supports the Severe Weather Forecasting Programme project in Southeast Asia. The regional centre there is in Hanoi, in Vietnam. And the map here illustrates an example of type of product that they make available on the website, which those regional Met services within the area, so countries like Thailand, Cambodia, Myanmar, can access just on an internet connection. And this particular plot is showing areas where they expect to have rainfall exceeding 50 millimeters per hour, 50 millimeters in 24 hours, or indeed in the darker color, greater than 100 millimeters in 24 hours. And you can see on the caption, there could be strong wind warnings on there as well, but there isn't in this particular case. And they can access forecasts for days 1, 2, 3, 4, and 5 ahead. So this is a useful indication to countries of when they're at risk from these severe weather effects. And you can see down the left-hand side links to various other bits of information and things that people can access as well. This is another example from the second project that was set up in the Southwest Pacific, South Pacific rather, where the guidance comes out from the New Zealand Met Service and supports a lot of small island states in the Pacific, as you can see on the map there on the left. And they present their guidance, well, their guidance is a slightly different way. What they've done here is, in this particular chart anyway, is highlighted areas of the ocean which are prone in this particular situation to large waves, and it gives them estimates of the wave heights and things. and it also gives an estimate of confidence in that forecast. And so again, and obviously this very oceanic region with a lot of small islands is particularly vulnerable to large waves and that sort of thing. So, and strong winds. So that's relevant
2 minutes, Ken.
Okay, thanks, David. Here's just another few examples of the types of products that are used in that particular region. So they actually provide weather maps showing the key winds and flows and pressure systems. The example at the bottom is an ensemble meteogram. So an example of showing, well, in this case, it's for a particular location, Rarotonga, and it shows cloud cover, precipitation, wind speeds and temperatures. And the little diagrams, the box and whisker plots, are showing the range of uncertainty through ensemble forecasts in this case. So that's just a couple of examples from there. Now, this has been, it's very much also a capacity development project. It allows, we provide a lot of training and things directly associated with the project. So WMO provides training workshops and things covering two aspects: forecasting, so helping people to learn how to interpret and things, the products, sort of products and things I've been shown, and turn those into weather forecasts, but also service delivery, how to build the relationships with, for example, disaster risk organizations within your country, so that actually the warnings can be acted upon and the warnings go to the right people, they're communicated effectively, and people take action to protect people's lives and properties. And one of the big strengths of providing this training through this SWFP program is that once people have had the training, they also have access to forecast data when they get home, so that they can actually put that training into practice and turn it into real services. So there's a lot of strengths of this approach. It provides an operational service in support of multi-hazard early warning systems. And I put the example, another example, a meteogram on the right here, which is specifically covering some ocean effects. It's got wave heights and wave periods and things in there, as well as wind speeds. And it makes use of this cascading forecasting process to facilitate operational service for provision of NWV products, satellite information, and severe weather forecast guidance to the regions of participating countries. Sorry, I'll just highlight here, there's some synergies with other operational systems and initiatives which follow the same sort of cascading process. Particularly, there's a flash flood guidance approach, which is implemented in a few parts of the world, the tropical cyclone program, and also particularly a coastal inundation forecasting program, which looks at storm surge risk. These all follow similar processes, but I think the SWFP is the most advanced and most fully implemented one as yet. But there's plenty of scope for implementing more of these. And I think I'm just going to finish with leaving this slide up in terms of the way forward, so in order to allow time for perhaps a question or two. Thank you, David.
Okay. Thank you, Ken. Yeah. Any questions, anyone?
Yeah, good afternoon.
Go ahead.
Good afternoon.
Hello?
Hello.
Yeah, I can hear you.
Hi. This is Mutiat from Nigeria. Hope you can hear me.
I can hear you, yes.
Okay. My question, before the question, this presentation now is a very good presentation because I work with the meteorological agency, which is in charge of weather and forecasting. So I really know little about this severe weather forecasting platform, of which in Nigeria, we were mostly concentrated on the inland forecasting on that platform. Right. I really want to know that how can it be possible for African country for the marine environment, how can we key in into this program? That is my first question. Then the second question on the coastal inundation forecasting program, the synergy, how possible for you to collaborate with us, because the Met office, according to what you've said, that the office from where you come from is a very good office that has been collaborating with other organizations, and in doing that, it will help us in our coastal flooding. So I want to know the avenue or the channel from which we can collaborate on this. Thank you.
Okay, so the reason for giving this talk, in a way, this is a best practices conference, and it was to kind of illustrate what we consider to be best practice in meteorology, in weather forecasting. So you're quite right, of course, that what I've shown is mostly providing guidance for inland areas. It's not specifically for coastal stuff, but it was to illustrate what I would suggest would be a really good model for the ocean forecasting community to follow in order to be able to spread information effectively to countries which can't generate it for themselves, because it's worked really well in meteorology. So the main purpose of this presentation was to illustrate this as a best practice approach. The coastal inundation forecasting process, which I mentioned, is a project which tries to do that already in a few parts of the world for coastal inundation. But I think there's scope for the ocean community to expand that a lot more. In terms of collaboration with the Met Office, I can't really comment very much on collaboration on the ocean side. I know there are a couple of Met Office people here in the conference who may be able to comment on that either right now or perhaps in the chat or something like that. But they would know more about the Met Office's possible collaboration opportunities in terms of ocean forecasting.
Okay, thank you.
Hey, thank you. Yeah, I'll put a comment in the chat, or Andy thought I might. I'll take one very quick question from Frederic, but if Ken, you could please stop sharing and our next speaker load up the presentation while Frederic asks her question.
Hi. My name is Frederic Bonou. I'm from Benin. I'm a researcher and a lecturer and oceanography. I won't try to provide a response for the question of Shola regarding the forecast system in West Africa. And she said that in Nigeria, they are doing forecast system inland. I can say in Benin, we all have developed, a system of a forecast system that provide information on wave state, wave propagation, wave direction. And this system provide information each 2 days. And this information is stored in a site. And people, but this information is in French. So people, fishermen, can receive the information about what can be maybe the wave situation in two days. So I think in West Africa we are trying to do, but sometimes there are a lack of collaboration. So I think this system is provide information not only for Benin but from Ghana to Nigeria. We have this information, and people from all these countries can use this information. I think apart of that, we have a program called MESA. For this program, they have a system like a forecast system that provides information about chlorophyll concentration. This information is hugely important for fishery, so they can know where can be the high zone concentration of fishes. So I think we are trying to do a lot of in that case, but a lot of effort are still needed. Thank you.
Thank you. Yeah, that's very interesting. And I think I just mentioned very briefly, of course, that there is, I think the lady from Nigeria said this, that there is a SWFP project which is centered in Senegal, in Dakar in Senegal, which covers West Africa. I don't know exactly which countries it covers. And if that is only providing inland stuff, it's worth contacting them, perhaps contact them through the regional association or contact Dakar directly and ask if any more information can be provided on coastal risks as well, because I'm sure they will have access to at least strong wind information and possibly wave and swell information for the ocean or along the coastline as well. Thank you.
Okay, thank you very much. We better move on, but please take a look at the chat. There's more in there. Our next talk is from Oleda Sholademi. Are you there?
Yes, I'm here.
Okay, yep, please share your screen.
Yeah, good afternoon, everybody.
Yeah, it's not in presentation mode. If you could make it full screen.
Sorry, is my screen seen?
We can see it, just not in presentation mode.
Okay, okay. Thank you. Yes,
Okay. Yep, thank you.
I really appreciate the opportunity given to come on board to present to you today on the impact-based weather forecasting to enable better decision-making and risk reduction in the marine ecosystem. I work with the Nigerian Meteorological Agency and in the Department of Marine Meteorological Forecasting Unit of the Directorate of Applied Meteorological Services. The very mandate of the unit under my mate is to provide weather and climate information to marine users at the sea and the coastal area for all the geophysical and oceanographic conditions. So doing, the weather, as we all know, is one of the severe factors that place maritime activities at risk. So therefore, there is need for us to make a forecast of the weather and provide early warning that will enable better decision-making, that will improve productivities, and which also reduce ecosystem services. There is the different events that takes place over the ocean. There is a question that I asked here, that do marine weather events have impact, which we all agree with me that it is yes. It has impacts, and there are 4 categories that is mentioned here: the low impact, the moderate impact, the high impact, and the extreme impact, which affects the people, the society, the economy, and also the environment at large. Now, the impact weather forecasting and warning services, what is it all about? It's all about noticing the elements that can cause threats like wave, wind, tide, excessive rainfall, and also disengaging the mind of all the forecast uncertainty, which comes up as a result of excessive time, length of period in making forecasts. And it will also streamline it to who and what may be affected in all areas where a hazard may occur. And it will give us an insight on the impact of the people that is exposed to it, either their livelihood, their property, and also to suffer those that can suffer bad effects when affected by that hazard. This resulted into a risk in some places, of which the impact-based forecast we addressed, that is the probability and the magnitude of harm that may possibly affect these people. Now, what is impact-based forecasting? is an all-encompassing approach to observing, modeling, and predicting severe hydrometeorological events and the consequent cascade of hazard through to impact. Looking at the WMO, which is the World Meteorological Organization review, it recognizes impact weather forecast as best practice according to the WMO number 1150 GADS. And also in WMO 112, it emphasizes that there is need to align with the WMO strategy for service delivery and its implementation plan that will help in assisting those that are in care of releasing such services to make it possible for the users. And this extend the development of forecast and warning in a manner that will allow the consequences of extreme weather hazard to be fully understood by users and appropriate mitigation actions to be undertaken. By so doing, governments, communities, and individuals need to become more resilient through actions to integrate weather and climate information, decision-making processes for better marine ecosystem. Looking at this, why is it important? Because it will allow it will enable those at risk to take appropriate action. It will improve planning for the different scenarios based on different impacts. It will contain information about the level of confidence in the forecast for better decision making, and it allows coordinating process to address disaster response and the preparedness, so that those that receive those information earlier will be able to use it judiciously. Now, does NIMET as an organization well positioned to provide targeted impact-based weather forecast for maritime industry? My answer should be yes, because presently NIMET is in the verge of providing targeted impact weather forecasts in a timely, disseminable manner and easily understandable approach to ensure risk reduction in the ecosystem. And the adoption of this WMO 1150 is also giving us a high priority in that manner. So we are disengaging from we are moving from the evolution, the initial point of what the forecast will be to what the forecast will do. So NIMET presently has developed impact-based forecast using a risk matrix to determine the warning. And this will give an information on the evolution hazard likelihood that is likely to occur, and also giving an identification of social and economic at risk. So how do we go about this? It involves partnership using different organizations that engage themselves in taking meteorological oceanographic information from the sea to come together and collaborate, and also to develop information and their services. That is, this different data, how we can use it to impact the society and how we can come together as one and produce a very good impact weather forecast. Then this can be done through technical tools, just like the database, the models, and also information, and also dissemination platforms, and the formats of producing that forecast, either graphically or coded or GIS layer. Now, these are some of the weather events that is causing havoc in the marine environment in Nigeria, like disruptive rainfall, thunderstorm, damaging wind, reducing visibility, and wave action that causes inundation and surging the coastal environment. Forecast processes and validation method in Nigeria. This information uses different models, just like the last presentation I said, and different either numerical weather prediction models or global models, of which NIMET is also involved. And our regional model we use is the Cosmo model that gives a true representative of what the ocean wave is all about and the weather, the precipitation characteristics in Nigeria. Then these are the processes that we engage in. We analyze our charts, we do the validation of the past information, we use the numerical weather prediction and satellite information. All these are the outcome of our information that we get from NIMET. And then thereafter, we come together and have a discussion on the information before we eventually produce the weather. This is a typical example of weather produced by NIMET, and the one that is being done over land. And that is the reason why we are here today, because we are trying to produce for the ocean environment, and by so doing, we have to engage the stakeholders. So to set up the marine met information, we are organizing a workshop of which different maritime organizations have been invited. This one will be coming up next 2 weeks to develop a communication chain with the Marine Meteorological Office of the agency. And this is the link to that survey. If there's still anybody that really wants to attend, they can send the link to you and we will give you the appropriate channel to attend if you are in Africa. Then these are the organizations we are looking at. We are looking at the government organization, emergency responder and business and so on, up to the media. So dissemination processes that we will be using is through our key stakeholders, such as the NIMASA, that is the Nigerian Maritime Safety Agency, NIMWA, that is the National Inland Waterways Authority, NIOMA, Nigerian Oceanography and Marine Research, Oil and Gas, and so on, and disseminated it through other channels and give us a feedback. In conclusion, though this is still under a processing, it is expected to bridge the communication gap between the weather agency and the stakeholder, also ensuring all stakeholders are aware of the decision to make and what action to take at different time and place when these warnings are issued. So success stories should be used as best practice examples and proof of concept among partners, stakeholders, and the public. So thank you for listening.
Thank you very much. Does anyone have any questions?
No.
Sorry, I think I dropped out for a minute there. Anyone have any questions? Okay, if not, we're running a little late, so please put any questions in the chat. And if we could move on to the talk by Luzco and Adiega, please.
Thank you. Sure. Can you see my chart, please?
Yes, but
Can
it's
you see
not
my
full
slide?
screen. We can see it, but not full screen yet.
Can you see it full screen?
Yes, thank you very much.
Yeah. Thank you very much for the opportunity granted me. And I will be presenting on a paper on operational hazard management. And the focus will be on Lagos. Operational coastal hazard management in Lagos coastal area and environs, the challenges and the opportunities. There is no, coastal area has always been known as an area whereby it has a large percentage of the population within 400 kilometers of the coastline. And urbanization activities have increased, and major activities that have been drivers to bring people down to the coastal region have always been the opportunities for tourist activities, for industrial activities, petroleum, and seabed mining and so on and so forth. So it has always been a place where is of great interest because of the natural endowment within that region. But it's unfortunate that this region as well, there are a lot of interplays of fluxes and of processes that goes a long way to affect this environment. And that's why issues that are of interest are always climate, coastal processes, sediment budgeting, most especially when it has to do with morphology of the coastal region. And human activities is the main driver that drive everyone, because they are the ones that actually make use of it. And as that will occur, where there's actually high concentration, multiple concentration of human activities, which can lead to devastating event. So of interest as well is the fact that sea level rises and storm surges have increased, and these have created a lot of threats to coastal communities. And thereby it is of great interest as well to know that issues of coastal flooding, coastal erosion, and pollution is of great interest. There is therefore the need to be able to prepare and respond to this risk in order to protect the fragile region, the fragile environment of the coastal region for sustainable development. And this is usually data-driven. In other words, because of the situation in this part of the world whereby you go searching for data, it's data scarce and it's very difficult to get some hydrometeorological data set that will be of interest, most especially when you are driving issues of coastal erosion, coastal flooding. It's always a very big task doing a lot of data mining processes to be able to get data set that you will use for modeling these activities. Lagos is well known for, Lagos coast is part of the Barrier Lagoon complex, and it has a coastline of 180 kilometers. The morphology of the place has shown that it has a high energy swell waves, which has a mean eastward long shore sediment transport of roughly 600,000 cubic meter per year, and between 600 to 700,000 cubic meter per year. That is the sediment trace. And the long-term morphology pattern have shown that there are two major issues that affect the downstream sediment distribution from the inlet at Komodo Channel. One is the accumulation of the sediment at the West Mole. Well, we'll show you the graph later. And then the disequilibrium that usually happen when it has to do with dredging, because of the dredging activities of the Komodo Channel and the lagoon, which have redistributed the sediment distribution. So of interest when it comes to Lagos coast, therefore, are the issues that happen before the moles were constructed. That is before 1910 to when the moles are constructed between 1910 to 1960. Then the issues that happen because of the coastal erosion and beach losses, most especially bar beach, that involves beach nourishing and dredging for new developmental sites. And after that, another issue that is of concern really is what is the Eco-Atlantic city? What is this there for? What's it doing? What is the long-term effect of it, most especially when it has to do with its entry? And the recent one is actually the Lekki Deep Sea. What is the focus? What are we to be expecting, most especially when it comes to the and it has been known as well that Updrift of the inlets has come uplift of the inlet at Komodo Channel, there is accretion. Meanwhile, the eastern downdrift, there is serious eroding activities. In fact, Bar Beach has been estimated that it has been able to reach a maximum recession about between 20 to 30 meters per year. This is the rate at which Bar Beach is being lost before the construction of the seawall. Another interesting thing is the fact that the Lagos coastal area is it's always affected by coastal flooding because of the low-lying terrain, which is as well as the effect of the sea level rise. Not to mention also the inadequacies of the drainage efficiency of Lagos. So Lagos City, apart from the fact that it is naturally prone to flash flood, issues of coastal flooding as well make the place to be subjected. And when it comes to during the rainy season, is actually a place of concern, an issue of concern. We're staying around the place. Another thing of interest is the fact that there have been a lot of sand mining activities, which has been going on in order to reclaim lands as well as create Miami Peninsula here and there. These has caused, studies have shown that this has caused a large-scale unstable sand mining activities that have resulted in a gigantic hole up to 8 meters deep on the once smooth ocean floor. This has a lot of consequences when you consider the effect of not only issues relating to saltwater intrusion to the aquifer, which have resulted even in the collapse of 2 or 3 mini water works in Lagos. And the land base as well is being, the instability is being, the structure is being affected because of the high load, because of the water. So large-scale land mining, large-scale sand mining is another activity that is of great concern. The Atlantic City, yes, which is Great Wall, has been able to save part of the erosive activities along the Bar Beach, but these have transferred the length of the erosion wave down drift, making places like Lekki and Co to suffer a lot. Of interest as well is the Lekki Deep Sea Port, which is within the heart of Lagos Free Trade Zone. And because of the dredging activities, it is evident also now that the port basin, if you look at the picture down here, you'll see that it's losing its beaches because there is serious erosive power that is taking the sands and washing them away. So there is need actually to have a control and systematic dredging plan, which will involve all stakeholders and be supported by data-driven science. This has resulted, therefore, into the disappearance of so many beaches like Alpha Beach, Lekki Beach. In fact, some residential areas has also suffered from coastal flooding and loss of waterfront of so many communities, with some communities going into exist. This is just a graphical illustration of what has been happening within the shoreline changes transfer over the years, and showing that in the recent erosive activities is increasing because of the massive anthropogenic activities. Yes, Lagos State waterfront infrastructural development have done a lot of things to provide infrastructure services along and control development along the Lagos waterfront, and in order to harness resources available there and protect the environment with a focus to attract tourists and for economic gain. But there's still a question to ask, because if we had to be able to really have a resilient and livable, flourishing Lagos mega city beyond the 21st century, we must be able to attain a management tool that will enable the application of manageable issues to a specific area and to achieve a desired policy outcome. And to do this, in my conclusion, in order to build, there are a lot of opportunities and reasons and ways and tools towards protecting coast, towards addressing coastal hazard. Some has to do with the software, with the hardware, soft protection as well, accommodating and reducing vulnerability through zoning activities and designing a new coastal model, most especially when it has to do with development of the waterfront of communities. And this will require a tailor-made coastal resources system management and planning, with a focus not just on the physical activities, but detailed human activities and be able to control such activities. It must be community-based. The urban waterfront development must be community-based so that they will see it as their project and they will be able to protect such projects. And not only that, it is believed that for us to be able to have a resilient Lagos mega city, we must be able to have an issue-based and adaptable management plan. What are the issues to be considered? What are we when it comes to the adaptable method that can actually be tailored to suit the environment? And another thing is the basic issues of mitigation practices must actually focus on the best approach now in areas of land use regulation and areas of enhancement of natural buffers, so that we be able to have a resilient Lagos coastal area. Thank you for listening.
Thank you very much. Does anyone have any questions? I will ask one very quickly. When you talk about engagement at the end, to what extent do you need to engage with government versus industry or the general public, or do you need to engage with all of those?
Thank you very much. Like I said in the presentation, there is need for us actually to engage all stakeholders, because we cannot be solving issues based on physical characteristics of the area without actually getting the users involved. Who are the users? Who are the one that is transforming this fragile environment? They are human. And not only that, government policies need to engage them and be able to be on the same plane to be able to address the issue. So I address them in terms of their cultural beliefs, in terms of their own future trend and sustainability, in terms of their livelihood. They will definitely will have a better resilience Lagos.
Okay, thank you very much. Okay, we had better move on to our final speaker, who's Jennifer Veitch If you could load up your presentation, please. Just to say again,
Sure.
if everyone could please note Jay's comment in the chat earlier to please leave your details if you're able to.
I think the previous speaker needs to stop sharing. Hello? Thank you. Okay, that's great. Yes, that's good. Okay. Right, so let me get this going. Are you seeing in presentation mode? I'm not.
Not in presentation mode.
Oh, gosh. Okay. Just when you think you have these things sorted. Okay, there we go. I think that should work, right? Okay. So,
yes,
hi,
right.
everybody. Thanks. Okay, I'm just going to introduce myself with my video on, and then I'm going to turn it off because I'm getting internet warnings. So I'm Jennifer Veach from the South African Environmental Observation Network. And I am really grateful for this opportunity to talk about South Africa's, there we go. To talk about South Africa's perspectives on operation forecast system best practices, or more particularly actually operational forecast system reporting best practices. So in terms of operational ocean forecast systems, South Africa, I would say, is somewhere on the less developed side of the spectrum. And I think it would be quite instructive for me to spend some time here talking about the status of our developments, how it started, where it's going, and the challenges we face. Because I think this will help to provide some context for our perspective on the reporting best practices. So while the will to develop an operational forecast system for South Africa goes quite far back, it's mostly been advocated by academics at research institutions, but only quite recently has it gained real momentum. And this is because, you know, the oceans economy being highlighted as a solution to grow jobs and to increase our GDP. And this was ratified by the South African government in 2014. So given this ongoing and ever increasing exploitation of the marine environment, our Department of Forestry, Fisheries and the Environment, or DFFE, sits squarely in this Marine Protection Services and Ocean Governance workstream, which is designed to ensure that any exploitation is sustainably governed. So to this end, the DFFE, in collaboration with the CSIR, developed the National Oceans and Coastal Information Management System, or OCIMS. It is a portal that provides customized decision support tools for various stakeholders for effective governance of South Africa's oceans. So the tools are really quite tailor-made for the end users, who are stakeholders that range from, you know, the National Sea Rescue Institute, aquaculture industries, marine surveillance, fisheries, shipping, and so on. So here's just a little example of the harmful algal bloom tool that uses freely available satellite products to provide the South Coast aquaculture industry with a risk assessment of the likelihood of HABs occurring in key locations around the coastline. So while OCIMS provides easily accessible and understandable tools for the end user, the Marine Information Management System that is being developed by SAON provides long-term publicly accessible repository for all marine and coastal information for the more advanced user. Currently, however, there are actually no ocean models optimized for the South African coastline ingested into the system. And this is a bit of a problem. It brings us to SAMISANA. So that stands for the Sustainable Ocean Modeling Initiative, a South African approach. And one of the goals of SAMISANA then is, of course, to develop these ocean models optimized for South Africans' EEZ, either in hindcast mode to support research or forecast models to support operations and to feed into OCIMS. However, given our relative lack of capacity in ocean modeling, in parallel to the actual model development, we are also obliged to focus a lot on local capacity development so that we can ensure the sustainability of whatever forecast system we produce. So these goals support our mission, which is to develop a local hub and platform for the development of local expertise, as well as ocean models that provide useful and importantly open access information about the changing state of the ocean. So I have it on a colleague's good authority that Samisana means something like to work together in Sepedi, which is one of our 11 national languages. And this is exactly the approach that we are trying to foster, certainly in the modeling developments, but particularly in our supervision of a number of students as part of joint projects with various institutes, both local and international, on various subjects related to ocean modeling. So co-hosting modeling workshops as part of joint projects with outside partners forms part of our strategy. We're hosting a workshop in the following 2 weeks, actually. But crucial to this approach is that we need to ensure that there is a sustained effort. It's not enough to drop in and host a week or 2 week long workshop. We really need to think more about approaches that will do more than just plant the seed, but that will ensure, you know, long-term growth of our expertise. So collaborative projects are one way of doing this. Co-development of coursework with lecturers at historically disadvantaged institutes, mentorship programs, and so on. So our capacity development goal needs to focus on sustained solutions with a view to creation of a critical mass of internationally recognized South African numerical ocean modeling experts. So in parallel to the human capacity development, of course, we are developing operational products that are being integrated into oceans. These products add value to freely available satellite as well as global ocean forecasts, which are improving all of the time. And so they are beginning to do a really good job, or they are doing a really good job at the regional and basin scale around our coastline. These tools are being disseminated operationally and are freely available to all users, and in fact has already been utilized in a relatively high profile marine heatwave event in which a number of species washed up off our east coast because of thermal shock. So this is the low-hanging fruit for us, and for the operational model and satellite information that we get from CMEMS, we are really grateful. So the second part of this goal is to develop our own models optimized for our nearshore region that is not well represented by the global forecast models. So the pragmatic approach for us, being relatively under-resourced in terms of both humans and infrastructure, was to develop a limited area operational forecast model using a downscaled approach. But also, given that global forecasts are doing quite well at the regional scale, this really seemed like an optimal approach to downscale into those regions where the global models were not able to capture sufficiently. So the question was, where do we develop our operational forecast system pilot? So this is our coastline. There's a lot going on here. We've got a number of marine protected areas. Those are the yellow boxes. We've got a very dynamic ocean. We've got a very busy shipping lane, which basically intersects with this red ribbon you see here that is indicative of the fast speeds of the Agulhas current. We have a booming aquaculture industry on our south coast. We have rogue waves within the Agulhas current. We have deep sea drilling at the edge of the Agulhas and at the edge of the Agulhas bank here. We also have oil bunkering or ship-to-ship refueling. So the ships come down in their shipping highway here, and then they find shelter in Algoa Bay and they fill up their tanks. But this is right alongside one of our biggest marine protected areas and a number of really important bird colonies. So in fact, there already has been an oil spill within Algoa Bay. A few hundred birds were impacted. Luckily, it was a small incident, but we might not be as lucky in the future. So Algoa Bay became a very obvious location for our trial operational forecast system. And in addition to being a contentious and high-risk region, it is additionally a SAON shallow marine and coastal research infrastructure, or SMACRI sentinel site, which means that it is very well monitored. And we're also looking toward an integrated operational observing system in that region. So we have a lot of in situ observations there. So this made Algoa Bay an obvious location for our pilot forecast model. So this is the small bay scale model that we produced for Algoa Bay. We're using Croco. It's a downscaled solution. Our grid is created using Delft 3D. It's a curvilinear grid, increasing in resolution towards the coast. We have also Dockerized the tools to produce this model, making it easy to move onto a new server and also to implement in other key locations of our coastline. So this is a very simple approach that we're using, making use of the freely available global products that are out there. And having done a quick little evaluation based on the in situ observations that we have in the bay, excuse me, this model performed really well. So we were really happy with the results. We forced the same configuration with 3 different boundaries. They all performed fairly well, some of them better than others, and the ensemble mean performed best. And this is despite the fact that we had no assimilation, no data assimilation in this model. So this gave us confidence in the model. And so we ended up disseminating this information for all users. And so here's a nice little movie of the sea surface temperatures. And I guess while you and I can appreciate the value of knowing what the temperature is doing in the next 5 days in an animation like this as marine scientists, the user within Algoa Bay, our stakeholder might not realize how useful this is. They might appreciate the pretty picture, pretty movie, but they might not realize how it can be useful to them. So in order to provide something more useful to them, we've also implemented a really rudimentary oil spill tracking function in which particles are released from each of the 2 oil bunkering sites daily and tracked for the following 5 days. So it is hoped that aside from being potentially really useful in the case of a future oil spill, it will also give stakeholders the sense of how ocean forecasts or ocean information can be really useful to them, in challenges they face in the offshore environment. So we've produced something really, really simple. We've produced it with what we have at hand, the resources, the infrastructure, the people. It's just the start. And our list of things to do, as you can see, is huge. It's ever increasing. So it all seems particularly overwhelming in the faces of the challenges we're up against. And these challenges, in fact, were identified as common to Southern African countries at an ocean modeling workshop that was held at the Wyoming Symposia in 2019. And these challenges impact some of my neighbors more than they do me, for example. So we've got infrastructure challenges, bandwidth in some places. We don't have enough in situ data, but I guess no one does really. And for me, the biggest problem is our human capacity and the lack of it. However, on thinking about our challenges, when I try to think of them as opportunities, a slew of possibilities becomes evident. For instance, we could facilitate local development that supports bespoke solutions for the very specific challenges, as well as the very specific stakeholder needs of under-resourced nations. And this could be our niche in contributions to the various Ocean Decades programs. So to this end, when thinking about best practice reporting, I was trying to do a little brainstorm earlier this morning. The first is the obvious, where's your model? What is your model? What are your input files and so on? And then there's the also obvious, but I think it does need emphasis, is that your reporting on your systems should always be up to date and easily accessible. People should be able to find your report very easily. It should also be easy to read and designed for the particular target audience in mind. So for instance, if in South Africa, we might find it very challenging to look at a very high level report on data assimilation techniques because we just don't have that level of understanding yet. So it needs to be really designed for the particular audiences. So for me, what's obvious, if you're in my shoes, if you're under-resourced and you're only at the beginning of your operational forecast system journey, well, the first one relates to the obvious. The global forecasts that we use to produce our downscales should follow FAIR principles, of course, and that relates to the obvious. I would also be interested to know who the verified users are and how the operational information is being shared with them. And then another thing is, how do you verify end users in the case of open information? And then another two that I thought of was some indication of or a description of your data pipeline or your workflow from the model inputs to the products that support stakeholders. And finally, what would be really useful is a thorough description of your archiving strategies. And that's all I could think of for now, but I'm sure there's a lot more that will turn up as we move forward on our journey. Thanks very much. That's all from me.
Thank you very much. Does anyone have any questions? One question from me. How computationally expensive is your downscaling model?
It's not at all. That's what makes it really fantastic. We could run it on a laptop.
Okay,
yeah.
Great. Frederic?
Yeah.
Frederic, do you have a question?
Yes. Yeah, nice presentation, Jennifer. So I would like to know what model are you using? The animation that you show us, if it is a open model, if this model is available, do this model take account the sediment transports?
So Frederic, thanks for your question. So it's the Croco model, and there is a sediment application that goes with it. So it is possible to include sediment. This one doesn't, but it's possible to do so. And in fact, we will be presenting a bit on that at our Croco workshop the week after next, I think. Yeah.
Okay, well, I know Croco model. Thank you.
Yes, okay, pleasure.
Ken?
Thank you, Jennifer. Very nice talk. Somebody asked me a question in the chat about sort of more integrated services covering weather and marine environments, and there was also about sort of more fully system modeling approaches and things. I put a response in there, but I just wondered, you did mention on one of your slides very briefly the potential of using the high resolution NWP model data from SAWS. I just wondered how much you were sort of integrating with the South African Weather Service on a sort of integrated approach to both the modeling and to warning services and things, and whether that was something that's worth looking at in more detail.
Ken, thank you for your question. You broke up a little bit at the end, so I hope I didn't miss anything important. But in terms of the weather service, we are starting to work together, and in fact, they will be integrating their information into OSIMS as well in terms of helping us drive our models, which is really fantastic. So it's starting to happen, but I hear you, and I think SAWS should be our operational home.
Well, that's good. That's what we're doing. Yeah.
I mean, I would like to produce the ocean models and then to give it to SAWS to look after. In my ideal world, that's what would happen. Yeah.
I think the other aspect was the services and whether there could be a common approach to how you present products and services and perhaps warnings and things, which because it can often make it easier for users if they get everything from a single place and in a common format.
Yeah, exactly. I agree. I think I don't have anything to add, but I think you're quite right. Yeah.
Okay, and there's a question from Jay Pullman in the chat. How much user uptake is there in your current work?
So that's a really good question. I mean, that's why one of my wishes for reporting best practices was, how do you verify your users? Because we don't really know how to do that at this stage. We're making our information freely available, but because it's freely available, we don't have a login. We don't know who's looking at it really. So we need to figure out who our users are. Of course, we do have users who, you know, on the side, they'll come to us and they'll ask us, we need information about this event, and we'll give it to them. So we have those odd users. It's not very many at the moment, but we really don't know who's using the information outside of the people who come to us directly. Thanks. Yeah.
Yeah. Okay. I think that's quite a common challenge.
Okay.
Anyway, we are nearly at the end of the session. Before we finish, I would like to attempt to take a photo of everyone if we're able to. But before we do that, does anyone have anything final they would like to say or ask? Or would Fraser, Regina, or Jay like to say anything?
No, I don't have anything to say.
Okay. Okay.
Yeah, I had a quick question, or maybe more of a comment, but it was the South African approach is a good example of this downscaling or this cascading downscale effect. And it's, I guess an open question is what sort of, like in our reporting, but also in our structures for our ocean forecast systems, how we do stuff, what are things we need to do to enable whether it's present or future downscaling. And we may also never know what, when we do say a regional scale or a global scale, what are all the regional systems or the coastal systems or the harbor systems that will hook in? So how do we sort of future-proof our use so that we're not limiting users or limiting value added, say, forecasting activity that bolts into the things? So, you know, how do we create this, I'll say, Lego set where not all the Lego pieces are apparent yet. They'll arrive in the future.
Yeah. Okay. Right. At this point, I will stop the recording.